Hi, welcome back. In this video, we're going to continue to talk about composition of functions, but with respect to tables and graphs. In our previous video, we spoke about how do you create a function using two functions, right? So if we have, say, f of x equals 2x plus 1 and g of x equals 3x squared. How do we create a function composed of another one? And we use the equations to create a new function. Well, today we're going to find how do we evaluate tables and graphs for composition of functions. So the thing to think about here is you want to think about this as with respect to input. If I were to change the wording here, right, f is composed of the function g of x. Another way to think about this, right, is g of x is the input of f. Right? We're plugging in an entire function into f. And if I take the notation here of inputs and outputs, we can make sense of tables and graphs a little bit. So we'll do an example with a graph. We'll do an example with tables. And as always, if you have any questions, feel free to let me know. Don't forget to like and subscribe, as always. Let's get started. So here we have a graph. I want to evaluate the graph at this location, right? So what is the value of the function when it's composed of g at 2? I'm going to write this as f of g of 2. So a way to think about it is that 2, f is going to be composed of g, right? So g is going to go into f, but g is going to be composed of 2. So we're going to plug 2 into g and evaluate this component, right? You could ignore the other two pieces, ignore this part of the equation, and just focus on g of 2. What is the value of g at 2? So I got to go to 2 as my input, right? The x-axis will always represent the inputs. And the y value will always represent the output. So if 2 is my input, what is the value of g? Well, the g function is going to equal 6. So I can rewrite this as f of 6. Instead of writing g of 2, I can represent the value, which is 6. Now 6 will be my next input. But now I'm interested in what's happening at f. So I'm going to go to 6, and the value of f, or the value at f, will equal 4. Right? So in essence, I'm plugging in 2 into g. And the output of g becomes the input of f. Let's try another one. Here we have g of f of 10. 10 is the input, right? 10 is the input. Let's find out what the value is of at f. So when I go to 10, the output is 4. So f of 10 is equal to 4. I'm going to replace that. G of 4. 4 is the output of f. Right? So the output of f becomes the input of my next function. And in this case, it's going to be g. So now I want to figure out what is the value of g at 4. I go to 4, and g is up here at 4. What about g of 2? Now I have a function composed of itself. Continue to write the notation as we know. G of g at 2. So I'm going to focus on just this function by itself. What is the value of g when x equals 2? I go to 2. The value of g is 6. So I'm going to replace that with 6. 6 becomes my new input, which is on here. And I'm going to figure out what is the value of G at 6. So I go to 6. The output of G is 5. Yeah. So if we think about this as inputs and outputs, right? A function is composed of another one, meaning the input of one function, right, will result in something else. That output will become my new input. And I can follow my thought process there. Let's try the same idea with tables. So here's an example with tables. Before we begin using these notations, we want to look at these 3 columns. We have 3 different columns. X, like in the graph, always represents the inputs. And f of x and g of x will always represent my outputs. Right? There are other ways of just saying the letter y. Well, this represents the letter x. Inputs, outputs. So let's look at this. We have f of g of 5. I know that I'm going to plug 5 into G first. So I'm going to go to 5 as my input. If 5 is the input, what is the value of G? G becomes 6. So I can replace this with f of 6. Right? My new value for G is going to be 6. Now I go 6 is going to be my new input. I go to the input of 6. And now I'm interested in the value of f. F will result in 5. Yeah. Let's try another one. Here we have G composed of f at 7. So I want to figure out what is the value of f at 7. The input is 7. The value of the f function results in a 6. So now I have G of 6, right? I take my result, and it'll be my new input. So I go to 6, and now I'm interested in the function. What is the value of G of x? 3. Here we have another function composed of itself. We have f composed of f at 7. So what is the value of f at 7? I go to 7. F is valued at 6. The output is 6. So I replace that with a 6. Right? 6 is my new input. And I'm going to plug it back into f. So I go to 6. What's the value of f? 5. What is the value of a function at this location? And we can do that with a graph. We can do it with a table. We can do it with equations, where you're plugging an equation, a number into the equation. There's a lot of ways to do this. I hope this has helped. Please let me know if you have any questions. Don't forget to like and subscribe. And as always, we'll calculate.